Welcome everyone, and welcome to the AluVET Vocational Training and Education for the Aluminium sector. This training is co-funded by the Erasmus programme of the European Union. I am Jan Lukaszewski, the Technical Manager of the Aluminium Federation in the United Kingdom. The Introduction to Metals series of modules explain the simple theory of metals and of metallurgy to enable students in subsequent modules to understand aluminium, its alloys, how aluminium is heat treated, how it is rolled, extruded and/or welded. In this module, we shall learn about the properties of aluminium. We will appreciate just how wide and diverse the aluminium properties are. We shall briefly identify each property, explore it, and identify potential applications. This knowledge will allow the correct application of aluminium. This project is funded with the support of the European Union. This publication reflects only the views of myself and the Aluminium Federation, and the Commission cannot be held responsible for the use which might be made of the information contained therein. This module explains the full portfolio of the properties of aluminium. It identifies and lists all of the properties. It picks out some of the least known properties to give a holistic picture. It also gives an insight into all the properties of aluminium and explains their advantages. Thus, this module explains why aluminium is a strategic metal and highlights many of its potential advantages over other metals. This module will give you an insight into the advantages of aluminium over other strategic metals and materials and explains the properties of aluminium. Through understanding the whole range of aluminium properties, you will be able to exploit aluminium to its maximum benefits. You will be able to substitute aluminium correctly for other metals and materials, including plastics. You will be able to design products to maximize the properties of aluminium. Aluminium is an element. It is a metal, one of nature's building blocks. Aluminium has an atomic number 13. So it has 13 protons in its nucleus and 13 electrons. Aluminium is one of the 5 strategic metals. Strategic metals are those that are essential to society and man. Copper is used for conduction of electricity, but perhaps its most important use is in munitions. Copper is used for bullet and shell cases, hence its price reflects conflict in the world. So today there is a global shortage of copper. Steel is the most dominant metal used virtually in absolutely every part of global society in everyday use. Titanium blends strength with weight, An important use of titanium is in surgical implants. Bone grows into and fuses with titanium. Magnesium is the lightest of all metals and has the lowest melting point and is becoming used more and more in space exploration. Now, aluminium is unique in that it is the most abundant metal in the Earth's crust and has an incredible portfolio of properties that span those of all the other metals. So aluminium is therefore multifunctional and is substituting and displacing all other metals, even plastics and carbon fiber. Now, aluminium is a light metal. It is roughly a third of the weight of both steel and copper. So the density of aluminium is 2.7 grams per cubic centimeter. The density of steel is 7.874 grams per cubic centimeter. So aluminium is a light metal, roughly a third the weight of both steel and copper. Now, we all talk about lightweighting and we all talk about lightweight cars, but lightweight in a shopping bag is as important as in the design of a car. You carry a bag around, you put the bag in your car. You've got aluminium in all its forms and products is transported. So even a soft drinks can, a pop can, is lightweighting. That soft drinks can is produced, it is conveyed by lorries, it is stored on shelves. You pick it up, put it in your shopping bag, put it in the car. So lightweighting is not just lightweighting the cars. Lightweighting is absolutely everything. It is lightweight aluminium that enables the building, the cladding of these ultra high skyscrapers that are popping up across the world. Now, these days, there are aluminium alloys and tempers whose strengths can match many automotive and architectural steels. So we've got a light metal with strengths that can match a lot of steels. Specifically, some of the aluminium alloys and the higher tempers that we've got available today match the tensile strength of about 90% of architectural steels and about 80% of automotive steels. So substituting aluminium for steel typically achieves a 45% weight saving, 40 to 45% weight saving without compromising steel. So lightweight aluminium can match the strength of many steels, but give you a 40% weight saving. Aluminium is the dominant metal in aerospace in aircraft. And it's dominant in aircraft because it combines weight saving with strength. Now, everybody is talking nowadays about lightweight cars and lightweight automotive vehicles, where aluminium is the dominant metal of choice. Let's look at one of the least known properties of aluminium, electrical conduction. Aluminium has 61% the electrical conductivity of copper on a volume basis. So if you've got a 2mm diameter wire of copper and a 2mm diameter wire of aluminium, aluminium would be able to carry 61% of the electricity of copper on a volume basis. So it's the same conductor. But aluminium has 200% the conductivity of copper on a weight basis. So if you match the weight of copper with the weight of aluminium, now you can carry 200% more current, more electrical current. Now that means that in a C series car, a large or larger medium car, if you change from copper to aluminium, you're going to save 12 kilograms in weight. Remember, there is a copper shortage in the world at the moment. And in the United States, aluminium is becoming to be used in domestic wiring rather than copper. If we change high voltage transmission cables from copper to lightweight aluminium, we can space the pylons further apart, reducing the clutter in the countryside.